about the top 5 solar mistakes, or the top mistakes that beginners always make. I started off doing the top 5, and I may have stretched it a little bit and gone over a little bit. So, solar is super exciting when you first get involved with it, and there's some mistakes that most of us make, and I'm going to admittedly say there's several that I made. Most of these are things I did wrong that I've learned over the years that most other people also do. They're not uncommon. It's nothing to be ashamed about. It happens. You get into something, you get in a hurry, and you do things hastily, and then you find out after you've tried it, or you hear later that what you're doing isn't either safe, it isn't right, or it's wrong. The ones that aren't safe are the ones that are really concerning, and those are going to be some of the ones that I will really focus on and try to drive home for you so that you understand the importance of them. It's one thing to buy something, have it not work, and you have to buy another one. It's another thing to buy something and have it cause a fire or cause you real problems. So that's what we want to avoid. When I started, I made a lot of mistakes, and I'm going to talk about several of them here today. The problem with mistakes is that a lot of people try not to talk about them, and they try not to expose the ones that they've made, and then other people can't learn from them. So I'm going to expose myself a little bit and show you some of this, tell you some of the things that I've done that were some of them that were dangerous, and some of them were just downright funny. I can even remember one of them, my wife just point blank laughing at me and saying, just fix it and move on. Okay, so the goal here for this one is to save you a little bit of time, a little bit of money, and a lot of frustration, because there was one that just frustrated me so bad. Let's talk about the first one, though, is undersizing the system compared to actual energy needs. It's really important that you understand your energy needs and how much power you really need, and understand how that relates to how much you can realistically collect. And I'm going to give you a really simple rule of thumb that I gave to someone else earlier today in a consultation, that if you've got, let's say, 1,000 watts of solar panels, you can pretty much count that the best you're ever going to get is 5 to 6 times that in power coming in. No matter where you live, you're not going to get a whole lot more than that. Now, 5 to 6 means that you're going to get between 5 and 6 kilowatt hours of energy collection a day. Now, if you're using that energy while you're collecting it, and let's say you have an air conditioner running, you may not actually get to store but a third of that or half of that. So that's something that you have to keep in mind. The first thing you want to do is, when you're sizing a system, is understand that the solar panel size is based on their best peak performance. Where you live will have the ability to, and we'll get into a little bit later, a website where you can go and you can say, here's the size of solar panels I need, and for your area it'll give you an idea of how much it is. But you're trying to create enough energy that you can store it so that later you can use it on a rainy day. It's kind of a funny way of putting it, but I think the statement should have been created from the solar industry. So underestimating how much actual energy you need, and underestimating what all that energy is being used for. So for example, if you've got 1,000 watts of power coming in, and it says that you're going to generate 5 times that to the day, so you're going to have 5 kilowatts of energy generated. The problem is what most people don't realize is that the inverter itself, in order to bring that energy in and to store it in your battery, there's some usage or some leakage of it. In other words, to run the electronics that take it from the solar panels, that convert it to the right voltage, being your charge controller, and then to store it into the batteries, are not 100% efficient. It's not a matter of you pour a gallon of water out of a bucket and you get a gallon of water in the bucket at the bottom. It's a matter of pouring a gallon of water from 100 feet up, and how much of it make it to the bucket at the bottom then. Not all of it. Now, the efficiency has gotten much better, but understanding that there are losses with every time you convert this power can give you an idea that 1,000 watts of panels, on the best day you're going to generate 5 kilowatts. On the best day, only 4.5 of that's going to go into your batteries. And I'm not using actual math here. I'm demonstrating what I mean by it. So please don't hold me to say, well, the percentages don't work. The theory works. The percentages may not be precise. So there may be like a 10% loss in that power, meaning that instead of 5 kilowatts you have go in, only 4.5 kilowatts go into the battery. But now when you take that power out of the battery and convert it to AC power again, there's another loss, and you may only be able to get out of it, 3.9 kilowatts that gets generated and put into your AC outlets. So for 5 kilowatts of generation, you get the availability of only 3.9 kilowatt hours of energy. And so there's some losses there that everyone has to be aware of, that when you generate this power, it has to be stored, and that's where the storage, the moving it to the storage and taking out of the storage has a cost for all the electronics in the middle to do all the conversions and transfers and moving over. That's kind of the easiest way to look at it. And every one of them have a little piece of loss here and loss there that you have to take into account. Underestimate or overestimating how much panels produce is probably the biggest problem that I have seen. Somebody says, well, I got 1,000 watts of panels and I'm going to generate, for 6 hours a day, I'm going to get 6 kilowatts a day. And chances are that's not what's going to happen. If you've got 1,000 watts of power and you've got 6 hours of good daylight, then those panels are going to start generating a little at the day, and there's going to be a peak where they generate that amount, and then it's going to start to drop off again at the other side. So there's going to be a curve of you generate nothing over here, and it's as the sun comes up, it starts to go up, and then it peaks in the middle of the day. For example, here and I can show you, maybe I can even show you and demonstrate that to you, because it's a really important concept. I can use my home assistant. Let's see, RV dot, there we go, that should do it. That did it. Okay, let me see if I can switch this over so I can show you. So if we look at the solar generated, and you can see in this chart over here, power usage. Let's see if I've got one that just shows me power generated. Let's do PV, and let's do total PV. This amps maybe? There we go. So here is the amps that are generated throughout the day from a solar system. And as you can see, as the sun comes up in the morning, you're only generating a little bit of power. And this might be better demonstration if I showed it to you in watts as opposed to maybe this one. There we go. That's the same thing, only this is in watts. So this is direct correlation to the power of your solar panels. So as you generate, you can see as the sun starts to come up in the morning, the solar generation is very small, and it gradually builds to the peak of the day here around right now it's 1:15, 1:16 in the afternoon for me. And then it starts to go back down all the way to the end of the day. So I may have solar power being generated from, a few minutes till 7 in the morning till almost 8 o'clock at night, being 13 hours, but I certainly aren't getting the 3,700 watts off of this that technically I would be getting from 13 hours of solar generation. So that is one of the biggest key mistakes that people don't understand, is that the best you're going to get is 4 to 5 times your solar panels. The most likely you're going to get is between 2 to 4 times. And so if you look at what I've got here, and we could just take this and say, okay, what am I generating in a single day? And I generated 19.7 kilowatts. I have actually I have both sets of panels here. So I got 16 generated off of the roof of the RV. There's 3,700 watts of panels on the roof of the RV. So let's see what formula that actually comes out to. So if I said I got 16.13 divided by 3.7 kilowatts of power, I got 4.3 times my solar panels generation. Now, you can get better if you have your panels in perfect spot and the sun's shining on them, you have exactly the right angle, and you can get a whole lot better. These panels are mounted on the roof of an RV, so they're flat. I'm not taking into account, the right angle and all of that kind of stuff. So please don't take this to mean that you can't get more than this. You certainly can. I'm just saying this is one of the largest misunderstandings that exist in building a system. Okay, so let's get back to the next piece of this. Buying cheap batteries that don't last. A lot of the times in the past, this was people buying lead acid batteries and things like that. They would make mistakes and they'd kill the batteries. There still are a lot of cheap batteries out on the market. If you're going to spend a lot of money on a solar system, please use some of the links that we've provided, that I've provided in the QR code, and look at the batteries that are there. Get a battery that's reputable. Some of these companies are producing batteries that simply don't have the right wiring in them. They aren't safe. The cells are cheap. They die quickly, and so on and so forth. On the good batteries, some of these batteries are going to be here long after we're gone. I mean, we're talking, 10,000 cycles on a battery that you cycle once a day is over 20 years of life expectancy on good batteries. So don't cheap out on the one thing that really is going to have the longest benefits for you. But at the same time, don't just throw your money at the most expensive, because that's not necessarily the best thing either. Batteries change from month to month. Just since I've been in the industry the last year or two, the companies that are producing batteries that were king 2 years ago, let's talk about some of those companies just had the massive Battleborn batteries, for example. They were just like king back 2-3 years ago. And now they're some of the most expensive batteries in the market. Are they good? Sure, they're good, but they're nothing compared to the stuff that's out on the market today for a tenth of the half of the price, or maybe even less than half of the price. So moving on. Mixing older battery types with newer battery types. Obviously, you want the same chemistry within your battery types. That's common mistake. If somebody says, well, I got some lead acid batteries and I'm going to buy some LifePod batteries. You really should stick with the same. There are some types that you can mix if you know what you're doing. Just make sure you get good advice and that you're very careful doing it right. You can limit the available battery strength of the more valuable battery by doing this. At the same time, you can also extend the life of your current batteries by doing it. So there are benefits and downsides, but that's a common mistake. Using undersized wire. So using undersized wire can have multiple hazards. First of all, you can have some serious voltage drop, which basically means that you're going to lose a percentage of all of your battery voltage, and that goes back to that percentage that we talked about earlier before. If it's 90% efficient, but you have a 2-volt drop in a 12-volt battery because you used the wrong size wire, that could cost you another 15% of your battery efficiency, just poof, gone, just like that, because of the wrong battery size. In addition to that, it can generate a lot of heat, and it can be a safety hazard if it's really undersized, where it gets too hot and burns up. So please just be careful with the undersizing your wire. Make sure you understand the right size wire to do. That's one of the things that doing it. In addition to wiring, and I'm going to give you a little bit of background on this. I made a colossal mistake when I was hooking up my system. I ordered some wire off of Amazon, and a lot of the wording out there, these companies know that we're newbies, we don't know what we're doing, and I ordered the first the first copper wire I saw. It came in, and I looked at it and I said, okay, that's great. And then I went to install it, and then I had someone online tell me that's not the right wire. And I started looking at it, and it said copper clad aluminum wire, but the aluminum part of it was in small print and kind of hidden in the ad. The title just said copper wiring. Aluminum and copper wiring are not even close to the same. What makes matters worse is I turned around then after doing that and ordered it a second time, but with copper the wrong size. So I had to replace the wiring to my batteries 3 times before I got it right. This is something that was just extremely frustrating to me because the wordplay on some of these items was intentionally designed to get me being a newbie and to cause me to order the wrong thing. And it wouldn't be so bad if it had just been the case of the money, but it was a case of it also wasn't safe. And for those of you who've watched the Solar Shed series, during part 2 of the Solar Shed series, there was a piece of that I replaced because I had reused one of those aluminum clad wires in a spot where I thought it might be big enough to handle it, and even for that system it wasn't big enough to handle it, and I had to replace it with a new copper wire. So wiring is easily probably the most dangerous piece to be wrong and to make a mistake. You want to make sure that you check all of them and all of your connections, all of your lugs and everything afterwards. So that's a really common mistake. Choosing the wrong charge controller. There are a lot of charge controllers out on the internet. There's a couple even on Amazon where the name of the company is MPPT, but the charge controller is PWM. But you have to go into the fine print to actually find that. So be very careful of the charge controller and understanding the difference between PWM and MPPT. And if you're not sure of that, then there's a video that I've got on the difference and how the two work. I'll link it here when we're not on a live stream. I'll go back and I'll link it for you. If you're here in the live stream, you can just go back through my history and you can find it over there. But it'll explain the difference in the two and why you would want the MPPT as opposed to the PWM. Forgetting about inverter surge is really thing. People see this inverter is 2,000 watts and they think, okay, well, my refrigerator only runs at 900 watts or my refrigerator only runs at 400 watts. I'm fine, everything will be great. I can tell you from experience, refrigerators sometimes surge 10 times their actual running wattage. I've got a little freezer that runs in my wife's coffee trailer that's a 93 watts when it's running, but it surges to 984 watts in order to start. So understanding what those surges are. Air conditioners are bad, freezers are bad, refrigerators are bad, all of them are bad. Even a little portable refrigerator. When the hurricane hit last year, I had a little portable refrigerator and I was trying to put it onto a little 300 watt inverter because the darn thing ran at like 28 watts or something like that. But the problem was I couldn't get it started with the inverter, the little inverter that I had for a 12 volt system. So I ended up not being able to use that refrigerator at all because I had no way to get enough surge to get that refrigerator to run. So be very cautious of that. It's very common when you, especially if you have multiple devices that are surging on at the same time. Example of that would be, especially in home air conditioners, where you'll have the fan on the inside, and a lot of those are now configured where the fan comes on, and then a few minutes later the air conditioner kicks on, or the air conditioner outside unit kicks on, and then a few minutes later the inside unit kicks on. But some of the older ones still have them both boom hit at the same time, and thus causing you some definite problems there. Not grounding or bonding incorrectly. This is a subject matter that I really don't like whatsoever. Grounding is a way to prevent you from being electrocuted. It gives the power an alternate route to going through you to get where it wants to go. That is what grounding is for. It is really super important because if it's not there, it will travel through you, and at the voltages that you're playing with here, it is the harm that this can do to your system is dramatic. You need to have a real respect for properly grounding things. Bonding is another story. Bonding the negative and the ground together should happen at the first junction box after the grid. So the grid comes into the house. If it goes into a panel, that's where the negative and the ground should be bonded and nowhere else. The idea is that grounding wire that comes from whatever device, when something goes wrong, it needs a completely independent path all the way back to that box, and not the negative wire that is already there. So that's kind of what the big difference is between the two of them. You want the bond at the first place where the grid comes in. You want the ground to be completely and totally isolated from the negative. And if you run into some place where those two are crisscrossed all the way through, especially in old houses and stuff like that, it really is best that you get an electrician in there to work on them and make sure that that stays safe. Because grounding and bonding, the regulations have changed so much in the last 10 or 12 years to make things safer for us and to make us safer. GFI plugs and stuff like that, a lot of people take them out thinking that, oh, this is a pain in the butt, it keeps popping. The fact is it's popping because electricity is going back the wrong way. It's getting away from it, and it's not all there. A GFI plug is basically an accounting procedure. If I send out 10 watts, I should get 10 watts of negative usage on this side. And if I don't have that double post accounting coming in, 10 watts goes out, 10 watts comes back, that's when the GFI pops. If you send out 10 watts and only 9 comes back, where did that extra watt go? With 1 watt, it may not matter. But 1 watt can also be an entire light socket of 60 watts or at 120 volts that could kill someone. So a GFI plug is made to detect that inaccurate return flow and stop the circuit and say, hey, hold on a minute, this isn't safe. That way, if you do get a toaster in your bathtub, that electricity flows down through the pipes that are grounded from the house, flows out the wrong way, and therefore the GFI can detect it. And that's why the bonding is important to be back at the main panel, and that's why the grounding is important to exist and properly be set up, and that's why GFIs are really a good idea and there to protect you. Although I did have at the last talk about frustrating, I did have a refrigerator. My primary refrigerator was brand new when the hurricane hit last year. I'd had it for about 2 months, and I'd never ran it off grid or anything like that. And as soon as the hurricane hit and we went to running off of a big power station box that I have, where it was plugged into a generator and everything, it kept popping the GFI plug. I mean, it was so frustrating because I had no other alternative but to run them through GFI plugs. The fact is there was a miswiring in that refrigerator that I never had known about and never would have known about until somebody got hurt. Eventually, at some point, somebody could have gotten hurt from it. But so GFI, grounding, and neutral bonding are very important, but understanding them is a very tricky subject, and it's not really one that a lot of people like to talk about. One of the common mistakes is you don't plan for maintenance or monitoring of the system. A DIY system requires maintenance. If you're not willing to do the maintenance, the DIY system is not there for you. There is no way around this. DIY systems have 1,000 little bitty parts. You've put them all together. It's no different than an automobile. You wouldn't dream of buying a car and not taking it in and getting it maintained, having the oil changed, having the tires checked, having the fluids done and everything. A DIY system is exactly the same. The difference is there is no auto dealer for you to drop it off at. That person is going to be you. And if it's not you and you're not willing to do it, you probably can't keep a DIY system safe. And I would advise you go with the off-the-box shelf solar generators and don't do a DIY system. Expecting the system to be a set and forget and not having to learn things and keep up with things is probably not going to happen either. You can do some of that, but for the most part, especially if you know somebody who can help you get one set up and help you learn to monitor it, that would be great. Yes, absolutely, cutie puppies. Give me just a second, and I'll be glad to go discuss that. And then we will. Expecting that a system to be set and forget is probably a bad thing. So let me kind of wrap this up, and then I'm going to get to this question that we have out there. If you are just starting out, avoiding these mistakes can probably save you a lot of frustration. Making sure you have good quality wire that someone that you know is presented. There's links in my description for wire. I always put it out there, and I will put that QR code back up there also. You can buy good quality grade wire. making sure that first of all, the temperature rating is of a good high rating. You know, you don't get the 45 degrees. Make sure you have the 70, the 80 degrees. I prefer the marine grade 105 degree temperature rating, and that it is pure copper. It can be tinned pure copper, meaning that it has a tin plate on it to protect it from water and moisture, like me, for that's marine grade. But it cannot be copper clad aluminum wire. Aluminum wire is not what you want for a system like this. The amperage ratings are completely different. Don't do anything to do with speaker wire, with radio wire, with car stereo wire. Any of those, a lot of those wires, a lot of them can claim that they can handle the amperage. It is not the same. I would love to hear if you've made some mistakes. Just put them in the comments for me. I'd love to hear what they are. If you're watching this on replay, please post them down below. I'd like to hear other people's mistakes. That I don't like to be the only one that screwed things up, and I screwed up quite a bit during this. Most of my mistakes were things that just cost me a lot of money, rebuying things and buying the wrong stuff the first time. I got very lucky on some of the big items and had done a lot of homework and didn't mess them up. Scan the QR code on the screen. All the links are in there. There are some affiliates links in there, so I do make some money if you use the affiliate links. If you call the company and you get their advice and then you use the affiliate link, I still get paid. If you call the company and place the order with them on the phone, I get nothing. So that's not an issue for me. If that's what you need to do to get your order right, please do so. I just want to make sure you're aware of it. And don't forget to subscribe to the email list. It's in the links below also. It will allow you to be in drawings in the future that we plan to have.